The following presentation will cover the very basics of meteorological forcings used in hydrologic forecasts here at the Arkansas Red Basin River Forecast Center, ABRFC. Information on the hydrologic model itself and the general forecasting process will be covered by subsequent lessons. I'm Mason Rowell, and let's get started. In this lesson, we will cover quantitative precipitation estimates, QPE, of past precipitation and quantitative precipitation forecasts, QPF, of future precipitation. The next lesson will focus on water loss from evapotranspiration, ET, and snowmelt. This flowchart demonstrates the complexity inherent to hydrologic modeling within any one basin. Each basin is considered as a closed system, aside from system inflows and outflows circled in red, which either introduce new water, for example, from precipitation, upstream inflow, and also interbasin flow through groundwater and overland exchange, not considered at the ABRFC, or cause water loss, for example, from evapotranspiration and outflow downstream. Accurate accounting of all water sources and sinks must take place in order to provide a suitable foundation for accurate hydrologic modeling, represented by the remaining processes depicted in this flowchart, i.e., the non-system inflows and outflows. QPEs are one of the most important forcings that we prepare daily at the ABRFC. Traditionally, mean aerial precipitation, MAP values, were developed once a day using a distance weighting routine that included a limited set of 24-hour precipitation data from co-op observers and automated precipitation gauges to obtain area averaged values for each basin, which are the smaller scale regions that potentially contribute water to the defined basin outlet. The advent of Doppler radar allowed us to create MAPX values at any time of the day, as this observation system permitted more frequent, higher resolution precipitation information. The hydrologic rainfall analysis projection HRAP grid is used in conjunction with these data to obtain relatively high-resolution rainfall estimates in an approximate 4x4 kilometer grid across the entire basin. Note that for both MAP and MAPX values, the resultant precipitation value is representative of the basin as a whole, or as we say, lumped, which will be covered more in future lessons and slides. The process of further refining those initial gridded QPEs will be described more in the next few slides. Unadjusted, or raw QPEs, typically consist of not only radar information, but may also include satellite data, numerical model input, and/or automated gauge correction. Experience at the ABRFC with creating QPEs over the past 25 plus years continues to show that these QPEs are often not as accurate as human quality-controlled QC'd QPEs. Therefore, we perform local bias adjustments to the hourly raw, radar-only, multi-radar, multi-sensor MRMS QPE product, upscaled to an HRAP grid, using an hourly precipitation gauge network that is QC'd by the forecaster for under or over reporting issues. MRMS has been shown to be effective at mitigating errors from most sources of anomalous propagation and can dynamically adjust to more appropriate reflectivity rainfall relationships based on its determination of precipitation type. However, bias issues remain with MRMS, for example, those associated with tropical rainfall regimes and hail contamination. Different sources of QPE, for example, dual pole or satellite estimates, can be used as the raw field instead, as these may provide better initial estimates in some situations. Regardless of the raw QPE used, errors will still be present. Thus, the human-based QPE-QC process occurs each hour throughout the day to mitigate these errors. See next slide for further details. Following receipt of 24-hour precipitation totals each morning, relevant hours will be further QC'd such that our 24-hour QPE more closely matches those totals, if the forecaster deems those observations to be representative of the storm total within the reported time frame, which again will be described further on a future slide. The program shown here is our Hourly Bias Correction Program, Process 3, P3. developed locally as an alternative to the National Multi-Sensor Precipitation Estimator MPE standard, as it is more efficient at adjusting QPE in our area of responsibility. These adjustments mostly involve altering the initial hourly precipitation gauge network with gauge changes, eliminations, and pseudo-gauge additions, but also may require manually altering the QPE in regions with sparse radar coverage and/or inaccurate estimates to adjust the raw field prior to gauge correction. The top field is the raw MRMS QPE for that hour, while the bottom field is the bias-corrected or processed field, using all the precipitation gauges shown. Our local bias adjustment uses distance-weighted interpolation to correct each HRAT bin along line segments terminated by gauges, see white lines in the raw panel, at which the absolute bias values are calculated. Bins not intersected by these lines are adjusted by similar distance-weighted interpolation between the nearest, already once interpolated bias values along nearby lines. Differences between the raw and processed fields are often subtle, as in this example, but when accumulated over many hours, these differences can be significant enough to cause a flood forecast to change categories when used in the hydrologic model. Currently, the ABRFC creates its hourly QPE by approximately 45 minutes past the top of the hour, but older hours may be updated as well as additional hourly data arrives. However, be aware that unless we are in 24-hour operations, QPE is automatically generated by MPE during the overnight hours. These hours of MPE QPE will be overwritten after P3 is run each hour by the forecaster following arrival on shift. The program shown here is a locally adapted version of X Windows Navigation, Animation, and Visualization, XNAV, which reads in Community Hydrologic Prediction System CHIPS data, and thus will be referenced as CNAV. CHIPS provides the hydrologic modeling framework used at RFCs and will be referenced more in future presentations. CNAV is the main platform through which we can view several sources of 24-hour or other durations of QPE, along with corresponding 24-hour observed precipitation totals, primarily to determine where differences exist between our initial 24-hour QPEs and these observed totals. In fact, the 24-hour QC process alluded to previously involves subjectively determining which hours within the 24-hour period are in need of further QC adjustments by examining these differences within CNAV each hour and then performing the actual bias correction to those hours in need of adjustment within P3 until our summed 24-hour QPEs more closely align with the observed totals. In this example south of Oklahoma City, our initial 24-hour QPE is only 58% of the 24-hour precipitation gauge observation, as seen within the areas circled in red, requiring this 24-hour QC process described to correct our estimate here. Care is taken to ensure erroneous 24-hour observed precipitation totals are not considered during this effort, which can be confidently screened out through interrogating observer behavior over time, using climatology, checking for gross errors, or coordinating with weather forecast offices, WFOs. Depending on the nature of the precipitation event, if multiple observations fall within one HRAT bin, priority may be given to observations we deem more reliable, or we may simply target the average of these observations, a method suitable for the type of lumped hydrologic modeling we do here, which is again addressed in future lessons. At the ABRFC, it is our policy to lean heavily on the QPF preparation that already occurs at the Weather Prediction Center, WPC, where experienced forecasters interact with numerical guidance to increase skill on spatiotemporal scales appropriate to the type of lumped hydrologic modeling we perform. More on this modeling in future slides and lessons. In some circumstances, it becomes necessary to improve upon the first 6 hours of QPF provided. For example, when current radar trends are not captured in the initial prediction, when the smoothed nature of the provided QPF is not appropriate to our faster responding basins, or when WPC is simply not able to provide this prediction in a timely fashion. which could be an issue for any 6-hour period of forcing. Keep in mind that during the warm season, March 15th to October 14th, we only use 18 hours of QPF due to the lower predictability typical of mesoscale-driven events common to this season, while in the cool season, October 15th to March 14th, we use 30 hours of QPF to leverage the higher predictability typical of synoptic-driven events common to this season. We are able to use up to 72 hours of QPF on an event-driven basis in circumstances where higher than normal predictability is evident. The event has potential to be highly significant, and when all of our impacted WFOs agree to this change, assuming non-impacted WFOs do not opt out. Keep in mind that if a WFO is serviced by multiple RFCs, it is very possible, if not likely, that each of these RFCs are using a different duration of QPF. In this example, RVF, you see the amount of QPF and the actual values of QPF per 6-hour period circled in red, as well as the summed total QPF at the top and bottom respectively. If you were ever confused about how much QPF is being used in the RVF at a particular forecast point, make sure to consult these sections. Be aware that the QPF detailed here is averaged, or lumped, within the local basin area defined for the basin outlet forecast point, in this case, BLUO2, and does not include any QPF that potentially impacted hydrographs in upstream basins before being routed downstream. Routing is a concept that will be covered in future presentations. We use the Graphical Forecast Editor, GFE, to finalize our QPF for the hydrologic model, including any edits if needed, where official is the final product to be used as forcing, and source is the initial field used to construct the official product. Note some of the alternative source examples shown here, which are available from the Copy From Model procedure. We may substitute with any of these alternatives, including older forecast initializations, in particular edit areas, like say a specific region we believe needs to be better characterized with a convective allowing model, CAM, or for the whole field, usually for only the first 6-hour period. WFO National Digital Forecast Database, NDFD, QPF is also an alternative we may use at the request of a WFO. Note that for specific regions in this same period, we may use the pencil tool to modify the initial prediction to better align with radar trends or other meteorological reasoning. We may also perform large-scale or localized changes to regions that appear too weak, aggressive in the initial prediction by simply using a multiplying factor greater than or less than a value of 1. In fact, the full suite of GFE capabilities is fair game for use, but those capabilities discussed are at least some of the more common practices here at the ABRFC. As a final reminder, our hydrologic model is lumped, meaning precipitation is area averaged in 6-hour time steps over the smaller scale basins that potentially contribute water to the basin outlet forecast point. Therefore, significant spatial variation in precipitation distribution throughout the basin can only be accounted for subjectively by the hydrologic forecaster, which again will be covered in future presentations. Also note that 5 full days of past precipitation are used by each model run, but most importantly, note that the actual area averaged precipitation used for either QPE or QPF in any 6-hour increment can be adjusted by the hydrologic forecaster. This adjustment may occur for several reasons. For example, the hydrologic forecaster has low confidence in the QPF amount or placement following coordination with the relevant WFO and/or his/her own experience. The initial observed hydrograph response cannot be reproduced without changing the recent precipitation amount, or because early 24-hour observed precipitation reports within the basin indicate initial QPEs need some degree of subjective bias correction. Keep in mind, however, that these adjustments are only made within the model and do not affect the official QPE or QPF published to the Advanced Hydrologic Prediction Service AHAP's website or on our own website. Adjustments made to precipitation by the hydrologic forecaster have a limited effect because, while they may indeed be necessary to force accurate hydrologic model behavior, considered alone, these adjustments may not be realistic, not to mention complexities in disaggregating the adjusted area averaged precipitation back into the original HRAP grid once again. Thanks for your attention during this lesson, and feel free to email me with any thoughts or questions.